Today we are working on 4.3 real zeros of polynomials, day 1. Finding all the possible rational zeros given a polynomial p of x, we need all the factors of the leading coefficient, denoted as q, and all the factors of the constant, denoted as p. We will then write all possible combinations of the ratio of the factors of p over the factors of q as we possibly can. So here I will show you our p-value is the 6 here, and our q value is the 2. Let me get a thinner marker here. So if we put p over q, and we're doing all the factors of p, the factors of p are positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. And the factors of 2 are positive and negative 1 and positive and negative 2. So what we want to do is come up with all of the possible combinations. So we're going to do 1 over 1, so positive and negative 1 over 1. We're going to do 1 over 2, so positive and negative 1 over 2. And then we're going to jump over the 2 and do 2 over 1, so positive and negative 2 over 1. And then we're going to do 2 over 2, positive and negative 2 over 2. And we continue doing that. So 3 over 1, positive, negative, 3 over 1, and then the 3 over the 2. So positive, negative, 3 over 2. And then we do 6 over 1, positive, negative, 6 over 1, and then finally the 6 over the 2, and we get positive and negative 6 over 2. So what we need to do now is simplify these. Here we have positive and negative 1 and positive and negative 1/2. Here I have positive and negative 2. Over here I have positive and negative 1 again. So I don't need to write that again. I can cross it out because we already have it. Positive and negative 3. Positive and negative 3 over 2. Go over to the 6, positive and negative 6. And then positive and negative 6 over 2. 6 divided by 2 is 3, and we already have that. So we can cancel that out because we already have this. Okay? And so now we can write our list in order with the whole numbers first. So we do positive, negative 1, positive, negative 2, positive, negative 3, positive, negative 6, and then go now to the fractions, positive, negative 1/2, and positive, negative 3/2. And those are all the possible zeros of all the possible rational zeros of the polynomial, written in order. So now let's look at the second example. We have a polynomial function and its graph over here on the left. We need to list all the possible rational zeros, and then part B, from the graph, we will determine which of the possible zeros are actually zeros of the polynomial. So again, we need to do the p over q. This time the p is 2, so we have positive, negative 1 and positive, negative 2. Those are the factors of 2. And then the factors of 3, we have positive, negative 1 and positive, negative 3. So less numbers, we will have less possible zeros. So I'm going to go over here and do my combinations. So 1 over 1, positive, negative 1 over 1, and 1 over 3. So positive, negative 1 over 3. And then 2 over 1, so positive, negative 2 over 1, and then 2 over 3, so positive, negative 2 over 3. So simplified, I get positive and negative 1. I'll go over here and get the 2, so positive and negative 2, now the 1/3, so positive, negative, 1/3, and then finally the 2/3, so positive, negative, 2/3. So these are my possible rational zeros. This is part A. Now part B, what I need to do is I just need to look at the graph here. Well, I have a 0 at -1. I could have looked at the graph and maybe assumed that it was -1, but it might have been negative 0.95. I don't know until I know my possible list of zeros here. So that's why this is helpful before we just start guessing from looking at the graph. So for part B, I know now that -1 is a possible 0, and therefore that is one of the zeros. Now, here we can see this is going every other hash mark is 1, as you can see there. So this is 1/2. Sorry for that bell. This is 1/2. So this value is between 1/2 and 1. Well, definitely not a whole number. 1/3 is between 0 and 1/2, so it's got to be 2/3. So positive 2/3 is the other 0. So those are our two zeros for part B. Now for this next example, we have to find all rational zeros of the polynomial. So first we need to list the possible rational zeros, and then we have to actually find which ones are the actual real zeros. So we have our p value is the 10, our q value is 1, and so we have our factors of 10. We have positive and negative 1, positive and negative 2, positive and negative 5, and positive and negative 10. And for q, we have positive and negative 1. So now, because we only have one factor for the denominator, we just know each of the numerators are the factors, the possible zeros. So we put positive and negative 1, positive and negative 2, positive and negative 5, and positive and negative 10. And so now what we need to do is we need to test these until we find possibly 3 zeros, because the degree of the polynomial tells us how many the maximum number of zeros there could be. And let me just finish here, the maximum number of zeros. Okay, so now what we need to do is we need to just do some synthetic division. So I'm just going to start with positive 1. I usually start with the lower positive values, and if I kind of seem to run into a roadblock, then I'll go into the negatives. So let's start with 1. And we write out our synthetic division. So 1, -4, -7, and 10. So we drop down the 1, and we get 1. 1 times 1 is 1, and then we add straight down -3. 1 times -3 is -3. Now we add straight down, and we get -10. 1 times -10 is -10, and when we add straight down, we get 0. And that's actually exactly what we want, because that, having a remainder of 0, tells us that the number that we tried over here is a 0. So a remainder equal to 0 means the tested value is a 0. Okay, so we have 1, 0 at x equal 1. Now what we need to do is, we don't want to go back to here and keep trying numbers. You can do that, but the easiest thing would be now to grab the polynomial you have here, and that's going to be x squared, because you decrease the exponent from the original polynomial down by 1. So we have x squared minus 3x and minus 10. And what we're going to do is take that polynomial, since it's a quadratic, we are going to try to factor it, or you can use quadratic formula, or if you have the program Quad 3 on your graphing calculator. So if you factor this, you will get x minus 5 times x plus 2 and equal to 0. And when you set each one equal to 0, x minus 5 equals 0 and x plus 2 equal to 0, you would get x equal to 5 and x equal to negative 2. So we have those are the other two zeros. So we did have three total zeros. So our zeros are 1, 5, and negative 2. And that's it. So if you have a polynomial here that is a starts with a degree of 3 and has 4 terms, you can try to factor it by grouping, or you can just do another testing of values with using synthetic division until you get down to a quadratic, so that you can just do factoring a quadratic or using quadratic formula. And that's it.